Hello everyone. In this lecture, we are going to study the classical physics, electromagnetism. Lecture series consists of the three parts. First part is the charge and electric field. Second part, current and magnetic field. And part 3, you are going to study the circuit. So this is the first part of this lecture series, charge and electric field. First topic is the electric field. Second topic is the Gauss's law. Third topic is the electric potential. Fourth topic is the capacitor. So first topic is you are going to study the electric field. Okay, first topic is electric charge and electric force. So you can find many similarities between the electromagnetism and the mechanics. We have studied the mechanics in the introductory course of physics. In the mechanics, we consider the motion of an object with mass. In the electromagnetism, we consider the motion of object with electric charge. The electric charge has a similar role with the mass in the mechanics. Object is accelerated by gravity in the case of the mechanics. Object with electric charge is accelerated by the electric force in the case of the electromagnetism. So let's review the structure of atoms. So this is a simple figure to describe the structure of atoms. In the atoms, a nucleus is located at the center of the atoms. Size of the nucleus is 10 to minus 15 meters to the 10 to minus 14 meters. Protons and the neutrons are located in the inside of a nucleus. These protons and the neutrons are bounded by the strong nuclear force. Surrounding the nucleus, electrons are distributed in atoms. Size of the atom is 10 to minus 10 meters. These electrons and nucleus are combined by the electric force. Okay, so to describe the small number, sometimes we can use a prefix. So for example, the thickness of papers is about 0.1 millimeters. So this milli means 10 to minus 3. So this is a prefix. So sometimes to describe the size of the cell, size of the cell is 1 micrometers. So this is 10 to minus 6. So size of the molecules, to describe the molecule, is about 1 nanometers. So nano is another prefix, is 10 to minus 9. So describe the size of atoms. Ten to minus 10 meters. So we have a special expression. This is angstroms, or size of the nucleus. We can use 1 femtometers. So femto is expressed 10 to minus 15. So sometimes we use a prefix to describe the small numbers. Okay. Then next topic is a proton, neutron, and electrons. Proton has a positive charge of the magnitude is expressed positive E plus E. And the mass is 1.673 times 10 to minus 27 kilograms. And the neutron has a zero charge. And the mass is 1.675 times 10 to minus 27 kilograms. a little bit heavier than the protons. And the electron is less massive, and its mass is 9.109 times 10 to minus 31 kilograms. Compared with the mass of the proton and the neutrons, you can find the electron is a light element. And the charge has the same magnitude with the protons, but negative charge. To describe the nucleus, we can use two numbers. So this point is 3. So lithium has 3 protons. So 3 means 3 protons. So this is 3 protons. Also, one more important quantity is the mass number. This is the sum of the atomic number and the neutron numbers. So in this case, the 3 protons and the 4 neutrons. So sum of the 4 plus 3 becomes 7. So we have a 7. I'd like to introduce the isotope. Some nuclei has the same atomic numbers but different neutron numbers. For example, lithium's 3. So this is the number of protons. So we have 2 lithiums, 3 protons. Automatically, lithium has the 3 protons. But sometimes the different number of neutrons they have. So this is 6 or 7. So sometimes the lithium has 3 neutrons. Sometimes lithium has 4 neutrons. So both atoms is stable. So this is 7.5%, 92.5% existence. Carbon has 3 isotopes. So all has 6 protons, but sometimes 6 neutrons, 7 neutrons. So it becomes the mass number becomes 13, 8 neutrons. So in the case of the carbon 12, it's stable. Carbon 13 is also stable. But carbon 14, too many neutrons, this is unstable. So we call it, this is radioactive isotope. So actually carbon 14 is decay into the nitrogen 14 by emitting the electrons plus electron antineutrinos. So using this method, actually by measuring the quantity of the nitrogens, we can determine the age of an object. So we call that this is radiocarbon dating. By development of the radiocarbon dating, Willard Libby won the Nobel Prize in chemistry, 1960s. So if we consider the similar charge, so positive charge and positive charge, for the case of the Q is positive, or Q prime is a positive, or Q is a negative charge, and Q prime is a negative charge. In the case of the product of the two charge is a positive one, then repulsive force is acting between the two charge. In the case of the one of the charge is positive, the other one is a negative charge, then product becomes a negative. In this case, attractive force is acting between the two charges. To express the magnitude of the force, electric force, we use a Coulomb's law. Coulomb's law said electric force is directed along the line of centers and varies as a product of the two charges divided by the square of the distance. We call this is a Coulomb's law. We consider two charges. Magnitude is expressed this one. Product of the q and q prime divided by the square of the distance. So distance between the two charges is r. And 1 over 4 pi epsilon naught. This is a proportional constant. This is a proportional constant. And the epsilon naught is expressed 8.854 times 10 to minus 12 Coulomb square per Newton times meter squares. So to describe the directions, we need to multiply the unit vectors. So this is a unit vectors. So unit vector, I'd like to explain the unit vectors. If you consider some vectors of A, this vector has a magnitude of the A. So magnitude becomes A. We'd like to find out the unit vectors. Unit vector has a magnitude of 1. So to create the unit vectors, you have to divide the original vectors by the magnitude. This unit vectors is expressed A over magnitude divided by magnitude of A. Then if you find out the magnitude of the U, then A vectors over magnitude of A. This is A over A. So it becomes 1. So you can find out how to create a unit vectors just by dividing by the magnitude. So in this case, if you divide the magnitude of the r, you can create a unit vectors. Then the direction is directed from the q prime to the q. You can describe the electric force in the vector form. Okay, this is the end of the first session.